Okay, so in this video, we will look at wave properties. Question number one, for a transverse wave, what is wavefront? It is always the line joining the points on either crest or trough, but they have to be the in-phase points. So a line joining all the points that are in phase with each other will be a wavefront. Question number two, what is one wavelength apart? So we can see that Y compression, Z compression. So compression to compression makes one wavelength. Question number three. So when something goes from deep water to shallow water, first of all, reject the frequency. This never changes. So it will be 1, 2, 3, all gone, only D. Speed and wavelength will change. Again, one wavelength. So this starting from the same point, starting from a point, ending at the same point makes one wavelength. Every other has a different distance. Number five. Which wave properties decrease? It will be again speed and wavelength. Frequency will be rejected and speed only will not change. It will, if speed changes, that is due to the wavelength that changes. Actually, when you go from a deeper to shallow water, the wavelength decreases because of the shallow water, and that makes the speed decrease. Number six. So we see that the ball is going up and down and it's not moving from its place. It is staying at its place, so it's moving up and down. The movement gives the energy to move. So energy is transferred. Energy and water are not transferred. Energy is not transferred, neither energy transferred, they're all wrong. So energy is transferred. Number seven. So when this wave reflects from this surface, the speed will not change and the wavelength does not change because in reflection, nothing changes. It just changes its direction. It's going to go like this and then it's going to go like this. Number eight. So IR cannot travel in vacuum, wrong. IR cannot travel in solid and gases, wrong. IR can only travel in vacuum, that is also wrong. So IR can travel in vacuum and in gases. That is the correct option. Number nine. Again, deeper to shallow water. Effect on all these three. Frequency stays the same, wavelength changes, speed changes. Frequency. It is the number of waves passing a point per second. Everything else is not the definition of the frequency. Number 11. Electromagnetic waves. Well, let's look at the B, C, and D. They cannot travel in vacuum. Wrong. They have the same frequency. No, they all have different frequencies. And they travel through lead. No, they do not travel through lead. That is why lead is used for bunkers and for gamma rays protection, because gamma rays are electromagnetic, the highest frequency, and even they cannot pass through a few centimeters of lead. And they are transverse? Yes, that's right. Number 12, you have to use this relationship, V is equal to F lambda. You're given frequency and you're given distance and time. From here, you calculate the speed and put in the values, you get this answer. Star explodes. What doesn't reach Earth is the sound. In IR does reach, light reaches, radio waves. They're all electromagnetic waves. They all reach. Only sound cannot travel in vacuum, so it doesn't reach Earth. A ripple tank, dipper moving up and down. What happens to the frequency? Remains the same. The speed, well, it goes here. The water becomes shallow, and that's why its speed will decrease. 10 kilohertz frequency, V is equal to F lambda, and the speed of light is given, and the wavelength is given. So you divide these two. Well, you have to try all of them one by one, unless you get a good guess at D. If you divide this by this, you get 10 kilohertz wavelength. Sorry, 10 kilohertz wavelength is given here. So that's why these are the only possibilities. Number 16. Energy is transferred by wave motion if, well, let's look at A. Colliding atoms in heat. There's no wave motion here. It's just the atoms colliding, transferring heat. Fast moving electrons. Again, these are electrons. And hot water rising, that is convection. So only D, the ripples through the water, that is a wave motion. Longitudinal wave is sound. Radio, wave on rope, and IR, they're all transverse waves. Remember, there are two types of waves, longitudinal and transverse. Longitudinal has compressions and rarefactions. It is going along the direction of propagation of wave. Transverse waves, the particles vibrate perpendicular to the direction of propagation of wave. And A, C, and D all transverse waves. Number 18. So if this wave goes, what will happen to the ball? Well, very simple. The ball will move up and down because of the crusts and the troughs in the wave. Wave has this frequency. How many waves in 1 minute? So 1 minute has 60 seconds, and 2 is the frequency, 2 times 60. Number 20. Well, it is the wave that is being reflected. So A is the choice. This one. So we have a vibrator that is vibrating, producing these waves, and then they reflect from this surface and they travel back. So I have made this one as reflecting back circle. So you can clearly see that if we try to place this, so this will be like this. Okay, so the waves will hit and then come back in the same pattern with the same wavelength. We know that in reflection, the wavelength and the speed does not change. And so in the choices, this will be the center, the point that is on the reflecting surface. So in the choices, we have 4 choices. So in the 4 choices, we have A, B, C, D. So very obviously, it will be this point from where the waves will go back to the vibrator. It will be like this. In this question, what is the speed of the wave? To calculate the speed of the wave, you have to consider distance time graph. So it is the wavelength given here, and in displacement time graph, it is the frequency. So we have the wavelength as 2 centimeters. We have the frequency as 0.04 centimeters, and the speed v is equal to f lambda. You multiply this with this. So I think this choice is given wrong. We have to change it. So if you multiply 2 with 0.04, you get this. This will be the speed. Number 23, which diagram demonstrates the type of wave produced by a source of sound? So it has to be a longitudinal wave. So A, there is no wave. C, there is no wave, just a stretched spring. D, there is a wave, but it's not a longitudinal wave. So B, there are compressions and there are rarefactions. So this makes a wave, and this is a longitudinal wave. And we know sound consists of longitudinal wave. Sound is a longitudinal wave. Number 24. Light question here. So, example of longitudinal wave. Is it A? Sorry, it's not a light question, it's a wave question. Example A, the light is not longitudinal. Example B, yes, there are compressions and rarefactions. This is a transverse wave, and this is also a transverse wave. So B is the correct choice. In 25, if you go from deep to shallow and you go like this, just you bend towards the normal, you refract towards the normal, so you bend like this. The reason for this is when this part reaches here, so this part, the bottom part, hits the surface first, and this hitting makes it slow down. The top one is still moving, so this slowing down bends it slightly towards the bottom. Number 26. So where is the wavelength, and where is the wavefront? So P, very obvious wavelength, so accept P only, reject C and D. So talking about A and B, so S is the wavelength, so it cannot be S, so reject B, only A left, so P and R is the choice. And anyway, when a wave going like this is the wavefront. Even if you don't understand, try the elimination method. Eliminate all the invalid choices, and you're left with only one. That is A. We have a wave whose speed and wavelength is given. Wavelength decreases. What is the speed in the shallow water? Well, look at this question. Speed, wavelength. So what we do here, from this part, we calculate the frequency. We calculate the frequency as frequency will be speed divide wavelength. That gives you 0.8. 0.8 will be the frequency. And again, here we have the wavelength. So frequency times wavelength, 0.8 times 0.8 gives you 6.4. That will be the speed. We will be using the same V is equal to F lambda here. When ice melts and becomes water, well, the force between the molecules changes, and that's why it is water. It is less bonding, less stronger bonding between molecules now. 29. The rate of evaporation, we have done this before. Only the depth that doesn't change it. So here again, we have wavelengths. We have the wavelengths decreased and the speed is given. And then you are sought to calculate the new speed. So again, use the speed and wavelength to calculate frequency on this part, and then use that frequency, multiply it with wavelength to calculate the speed on this part. I hope you can do it. So we have a wave and that is bending towards its right. So that is what is happening. Let's look at all the options first. A change in frequency, no, the frequency is same, it never changes. Change in frequency, reject the first two. The last one, change in speed due to change in frequency, again, changing frequency, not possible. So the only one left is this, even if you don't understand, okay? Now, why is this correct is because change in speed is due to the change in depth. And we have discussed this before, that when we decrease the depth, i.e. there is shallow water, the the bottom part of the wave hits it, so it makes it bend like this. So that's why the wave bends towards right in this diagram. So a wave passes from deep water to shallow water. This is the speed, this is the wavelength. Again, wavelength is given, calculate the speed, same process, calculate frequency on this side, multiply it with the wavelength, gives you the speed, new speed. What is meant by the term wavefront? We've done this before. Here, displacement varies according to this. So from here, we can calculate easily the frequency. It will be 2 seconds for one wavelength. So the frequency will be, so the time period is 2. So you divide the time period by 1 to get the frequency. And that reminds me one thing. We have to go back, and we have done one wrong ourselves. The option was correct, but we did it wrong because of the wrong interpretation of the graph. So this was the question. So yes, the option was 50, and that was right. So let me tell you why it is 50. So from here, you have the time period. It is not the frequency. Sorry, I do apologize. So you calculate the frequency by dividing time period with 1, and 1 over 0.04 will give you some number like 100. And then 1 over 4, sorry, it will give you 25. So 25 times 2 gives you 50 centimeters per second speed. So we go back to our question. So here again, we divide 1 over 2 by 1, 1 over 2, 0.5, and 0.5 is the frequency. 35. So we go back. So what happens in this case when the wave moves forward? These 2 points, well, when you move the wave forward, that means the Q goes up. Why? Because when the wave moves forward, the Q will go up. Well, I can't explain it in this diagram, but I can say that when this point moves up like this, obviously this will be here, so Q stays there, so Q goes down and P goes backward. So Q will move up. Here we have these. These are 1, 2, 3, 4, and 5 wavelengths. Divide 20 by 5 gives you one wavelength, 4, and 4 is the frequency as well. So 4 times 4 gives you the speed, 16. So shallow, obstruction makes the water shallow. This will decrease the speed because all three have the frequency. The wavelength is not mentioned here, but we do see that the wavelength is also decreased. So the only choice given here is only the speed decreases. So we will have to choose this one. Here, P is the amplitude of the wave and Q is the wavelength of the wave. It is also the period of the wave. So it is a tricky question. Let's see why it is saying Q as the period and not the wavelength. So the diagram shows graph of wave motion. It is the displacement and time. So it is not the length. It is not distance. If there was a distance here, Q was going to be the wavelength. So because this is a time, so that's why we have the Q as the period, and the period is the time that is to complete one wavelength. So that is why A is the correct choice. Transverse and longitudinal is radio and sound. Well, here water ripples are transverse, so reject this. Sound is longitudinal, reject this. Water ripples, radio is transverse, reject this. Only B is the correct choice. So this is a repeat question. Well, the data might be different. So we have the wavelength, we have the speed, that gives us the frequency. We use the frequency multiplied with wavelength gives us this velocity, V. It is a displacement distance graph, so the amplitude is 2. Thank you.